Hi everyone, good afternoon. In this lecture series, we are going to discuss about the decade counters. So, what do you mean by a decade counter? It is also called as the binary counter. It is designed to count from that is ones and zeros at the same time the decimal numbers, that is decimal value, that is 10. Here we are having an ordinary 4-stage counter. It can be easily modified to the decade counter by adding the NAND gate. So here the NAND gate outputs are connected to the clear input of each of the flip-flop. So this is the state diagram of the decade counter. So it starts from 4 zeros. Again 1, 2, 3, 4, 5, 6, 7, 8, 9. So the cycle repeats on from 0 to 9. So this is the truth table of the decade counter. So we are applying the clock count. So the clock count is applied as 1, 2, 3, 4, 5, 6. Likewise it goes on, and we are applying the pattern as QA, QB, QC, QD. So initially all the four values QA, QB, QC, QD will be 0, and the decimal value also 0. Again triple zero it will be 1, and again 0010 it will be 2. Likewise it goes on from 0 to 9. Finally the counter resets its outputs back to 0. So this is the logical diagram of the decade counter. So here we are using the flip-flops, that is JK flip-flop, and the Q bar is taken as the output. A supply is given and the clock pulse is applied to that of the each flip-flop. So here we are taking the output in the form of Q0, Q1, Q2, Q3, and finally it is given to that of the NAND gate, and the output is taken. At the same time the clock pulse is applied to all the flip-flop. So this is the decade counter timing diagram. Initially the clock pulses we are going to apply from 0 to 60. So initially the QA bar, so it will be, that is zeros and ones. It goes on from 0 1 0 1. Likewise the next one will be 0 0 1 1 0 0 1 1. The next one will be 0 0 0 1 1, and the last one will be 8 zeros and 8 1. Again we are applying the clear pulse, and that is termed to be as the reset pulse. So this is the timing diagram as what we have mentioned in the previous slide. So here we are having the clock pulses as 1 to 10, and for Q0 it will be 0101, for Q1 it will be 0011, for Q2 it will be 4 zeros, and finally for last it will be 8 zeros. So this is the excitation table for the flip-flops. So the present state, what are all the present states we are having is QA, QB, QC and QD. So initially the values starts from 4 zeros and 4, it ends with 4 ones. The next state will be QA will be QA plus 1, QB will be QB plus 1, QC plus 1 and QD plus 1. So what will be the next state? For example, if it is 4 zeros, the next state will be 001. So according to that we are writing the next state from the present state, and we are going to write the flip-flop inputs. So flip-flop inputs, how we are going to write means, suppose we are taking the JK flip-flop, so we are going to see TA, TB, TC and TD from the excitation table of the T flip-flop. We are writing the values. So and finally we are assigning the K map, that is K map has been initialized for this flip-flop. So this is the logic diagram. So how we are going to connect this logic diagram means, we are taking the T flip-flop. So I have taken 4 flip-flops, and with the help of AND gates and OR gates I have connected from the design, from the expressions of the K map. So and finally the clock pulse is also applied. So these are all the assessment questions. So we know that how we are using the decade counter, and what are all the difference between the synchronous and asynchronous counters, and how why we are going for these counters. Thank you.